That should be good enough. Get my picture real quick. Did they not test this before releasing it to the public? I'm sorry, I didn't know any good testing procedures. You haven't heard of test-driven development?
Good afternoon, everyone. My name is Christian Calhoun, and today I'm going to be covering test-driven development. As a brief overview of what I'm going to be talking about today, I'm going to be covering test-driven development in depth, the importance of test-driven development, as well as how it relates to the Agile software development. So first, let's talk about Agile. What is Agile? Agile is a philosophy of project management. Agile is a set of software development methodologies that are based on iterative and incremental development. The Agile Manifesto, which was created in 2001 by a group of software developers, outlines the principles of the Agile development. These 4 principles include individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract and negotiation, and responding to change over following a plan. So Agile software development is a flexible, iterative approach that emphasizes collaboration and customer feedback. Test-driven development as a development methodology complements these principles by ensuring a focus on delivering high-quality software that meets the needs of the end user. Test-driven development aligns with these Agile principles, particularly in the areas of continuous improvement, adaptability, and collaboration. So what is an iterative approach? An iterative approach makes progress through successive refinement. The development teams develops the first cut of the system, knowing in advance that some or many parts are incomplete. The team then iteratively enhances those parts until the product is satisfactory. With each iteration, customer feedback is taken into account and the software is improved through the addition of greater detail. What is an incremental process? Well, an incremental process involves delivering components of the software in parts, so usually typically smaller parts, but each increment represents a complete subset of a functional code and it is fully tested. I would say that's good enough. So, is testing important? Well, testing plays a critical role in Agile development, as it ensures software quality, uncovers and fixes defects early in the development process, and allows for adaptation to changing requirements. By integrating testing into the development cycle, Agile teams can consistently deliver high-quality software that meets customers' expectations while maintaining the flexibility to respond to new or evolving requirements. Testing in Agile also helps teams adapt to changing requirements and ensures that their software meets the changing needs of the customer. So what is test-driven development? Well, test-driven development is a little bit different. So test-driven development is a software development approach that involves writing a test before writing the corresponding code. So you build the test first and then you build the code. So the process begins with creating a test for a specific functionality, running the test to see if your code fails, and then writing the minimal code required to make the test pass. Once the test passes, the code is refactored and improved as necessary, ensuring that it adheres to the best practices and maintains a high quality. The cycle is repeated for each new functionality, resulting in a comprehensive suite of tests that validate the entire application. One of the core cycles of test-driven development is called red-green refactor. Red-green refactor is a continuous cycle of writing a test, running the test, and then making the changes to the code to correct for any errors. The cycle helps guide developers to write a code that passes tests and continuously improves code. The first section, red, is where you write a test that describes a behavior the developer wants to implement. This test is going to fail because you have not written any code yet. This stage is called red because the automated test framework will highlight the test in red to indicate that it has failed. The next stage is called green. Green is where you write the minimum amount of code necessary to pass the test. The code is written with the sole purpose of making the test pass. This stage is called green because the test framework will highlight the test in green to indicate that it has passed. The final part is called refactor. So you will refactor the code to improve its quality and make it more readable, maintainable, and efficient. The aim of this stage is to ensure that the code adheres to best practices and is optimized for performance. The refactoring stage is crucial for ensuring that the code database remains manageable and easy to maintain over time. The red-green refactor cycle helps guide developers to write code that passes tests and continuously improve code quality in several ways. The first way is that it helps developers focus on the task at hand. The second way is it promotes a test-first mindset. Thirdly, it provides a feedback loop continuously and quickly. And lastly, it promotes code quality. So let's talk about test-driven development in detail. Test-driven development can be broken down into 5 simple steps. The first step is to write a test. So you create a test for the functionality you want to implement, focusing on the expected inputs and outputs. Secondly, you would run all the tests, including a new test, and watch them all fail because you have not written any code yet. So thirdly, you would write the code, but only the bare minimum code necessary to make the new test pass. Next, you would execute the new test and the previous test you created to ensure that the functionality works as expected. Now you may have to complete steps 3 and 4 multiple times for it to work correctly, but that's the order you do it in. Then lastly, once everything works properly as intended based on your initial test, you would refactor the code. The reason you do this is you want to improve the code to ensure that it adheres to the best practices and maintains a high quality while keeping all the tests passing. So what are some benefits of test-driven development and why should you consider using it? So test-driven development has several benefits that lead to better software quality, faster development, and improved collaboration among team members. So test-driven development helps to improve code by encouraging developers to write clean, modular, and maintainable code that passes tests and meets requirements. This ensures that code changes are thoroughly tested and that any defects or issues are caught early in the development process, resulting in higher code quality with fewer defects. Test-driven development also promotes faster development by helping teams catch and fix issues early in the development process. By writing tests before writing code, issues can be identified and addressed before they become more difficult and time-consuming to fix, leading to faster development. Additionally, test-driven development makes debugging easier by providing a clear and step-by-step process for identifying and fixing issues, reducing the likelihood of introducing new bugs during the debugging process. Lastly, test-driven development promotes collaboration and communication among team members as it provides a shared understanding of code quality and a common framework for discussing and addressing issues. So test-driven development uses continuous integration. So continuous integration is a development practice where developers integrate their work frequently into a shared code repository, ensuring that the software is always in a releasable state. The primary goal of continuous integration is to identify defects early in the development process and reduce the risk of integration issues that can occur when changes are made independently. By integrating changes frequently, teams can catch defects early and reduce the time and cost associated with fixing defects later in the development cycle. So test-driven development is an important aspect of continuous integration. By writing tests before writing code, developers can ensure that code changes are thoroughly tested before they are integrated into the shared codebase. This helps catch defects early, ensuring that the software remains in a releasable state. Together, test-driven development and continuous integration can help teams identify and address issues early in the development process, resulting in faster feedback loops and a more efficient development. Continuous integration tools can automatically build and test changes when the code is committed to the shared repository, ensuring that the code is consistent, functional, and meets the established requirements. To maximize the benefits of test-driven development, it is important to follow the best practices, such as keeping tests simple and focused, testing one functionality at a time, writing descriptive test names, and adhering to the 3 laws of test-driven development. So simple, focused tests are easier to maintain and understand, while testing one functionality at a time ensures that each test is independent and can be run in isolation. Descriptive test names make it easier for developers to understand the purpose of each test and the functionality it covers. So the 3 laws of test-driven development were proposed by Robert C. Martin as a set of principles to guide developers in using test-driven development efficiently. First law is you should write no production code without a failing test. This means that before writing any code, developers should write a test that will initially fail. This ensures that the code is written only to meet a specific test requirement, rather than simply to fulfill a general objective. The second one is you should only write enough tests to fail. This means that the test should be written only to the extent necessary to verify that the desired behaviors of the code. The test should be simple, specific, and focused on a single behavior or functionality. The third law is you should write only enough production code to pass the failing test. This means that developers should write only the code necessary to pass the failing test rather than writing more code than necessary. This ensures that the code is not over-engineered and reduces the risk of introducing defects. The test-driven development fosters collaboration among developers, testers, and other stakeholders by promoting a shared understanding of code quality and encouraging collective code ownership. By writing tests before writing the code, developers are compelled to think about the desired functionality and requirements from the very beginning of the development process. This encourages communication between developers and testers, as well as other team members, such as product owners and business analysts. Test-driven development also promotes collaboration between developers and testers by encouraging communication and fostering a shared understanding of code quality. Implementing test-driven development may come with some challenges, such as writing tests for complex systems, resistance to adopting test-driven development, and balancing test coverage with development speed. To address these challenges, it is important to break down complex systems into smaller, testable components, providing training and support for developers new to test-driven development, and prioritizing critical tests using risk-based testing strategies. By proactively addressing these challenges, teams can effectively incorporate test-driven development into their development process and maximize its benefits. There are various tools and frameworks available to support test-driven development, including unit testing frameworks, mocking libraries, and test runners and continuous integration tools. These tools can help developers write, manage, and execute tests efficiently, as well as automate the build and test process to ensure consistent code quality. There are a couple complementary techniques that go along with TDD. First of which is TDD, which is Acceptance Test-Driven Development. That is a software approach that emphasizes defining acceptance criteria based on user requirements before starting development. TDD involves collaborating with developers, testers, and stakeholders to create acceptance tests that define the desired functionality of the software from the perspective of the end user. The second type of BDD is behavior-driven development. It is a software development approach that focuses on user behavior and common language to describe the test. By using a common language to describe tests, BDD encourages collaboration between technical and non-technical stakeholders. They are complementary because they focus on user needs and behavior, ensuring that the software meets both functional requirements and the user needs. In conclusion, test-driven development is a powerful technique for ensuring software quality and agile development. Test-driven development helps teams deliver high-quality software that meets customer needs by promoting collaboration, faster development, and easier debugging. Adopting test-driven development best practices and tools can help teams improve their software development process and reduce the risk of defects. By combining test-driven development with agile principles, software development teams can build software that meets customer needs and adapts to changing requirements. Thank you for listening to my presentation. Hope you have a wonderful day. Here are my references, including one from IBM.